Okay, before we take a look at number 49, I just want to mention that I'm moving at a rather brisk pace through these problems. And let me zoom out a little bit. So if you want a more detailed explanation, please refer to some of these other videos that are already posted in YouTube to review factoring, or if you want to see examples of factor by grouping or the box method in detail. Any of the videos from 11.4 show that. And I refer to these rules for factoring quite a bit. You do want to have these handy if you're trying to follow along. Okay? So now we'll zoom back in and get busy with our factoring here. I don't think that's going to work. I'll have to zoom out. Okay. There's no GCF, so number 2 is 2 terms. No. 3 terms, yes. Nothing in front of x squared. Well, okay, there's a 1, but I say nothing. So you grab your last term and list all the factors. Here's our 225, and listing all the factors. 1 times 225, 2, 3, 4, 5 will go in there. 5 times 45, because 5 times 40 would be 200, and then 5 times 5 would get us to 25. 6 won't work, 7 won't work, 8 won't work, 9. Since 9 is in 45, I got a feeling 9 will work there. So 9 times 25. Hey, look at that. 10, that won't work, because you can't cut 45 in half. 11, 12, 13, 14, 15 times 15 is 225. And I'm not sure how, I mean, if you're familiar with working with the numbers, these things will to some extent occur to you, but 5 times 45, you should be able to look at that and know that 25 will divide into it because it ends in 25, so you could just do that calculation. You should know that 5 goes into it, so you could just do that calculation. So you would come up with these even if you weren't sort of doing it in your head. The 15 times 15 might be a little trickier, but well, again, you have to work with these enough to get faster at them. But I was kind of thinking of the prime factorization of 45, and prime factorization of 45 is 5 times 3 times 3, and over here I've got a 5. So if I make a 15 with a 5 times 3, I've still got a 5 times 3 left. I know that might be hard for you to pick up on at this point. I've discussed this in some other videos. Anyway, if this is positive, we're looking, the signs must have been the same to get a positive. It was either positive times positive or negative times negative. That's how we got our positive 225. So we want a sum of negative 15. All right, both signs have to be negative. And is there any combination here that will give me a negative 15? There is no combination, so this is prime, and that's how you would answer it. Okay, that's 49. We'll take a look at 50. Do you notice that 16 is a perfect square and 25 is a perfect square? So the square root of 16 is 4. The square root of 25 is 5. 4 times 5 is 20. And if you add that to itself, you get 40, and that's our middle term. Okay, so it turns out this is a perfect square trinomial, and the factored form would be 4x minus 5, this quantity squared. Okay, it's a perfect square trinomial. If you're not well versed at identifying perfect square trinomials, if you multiply 16 times 25, you'll get a large number. But if you do that and list all the factors, you will be able to use the box method, and you'll come up with 4x minus 5. You'll come up with 4x minus 5 times 4x minus 5, and obviously that can be written in this form. Okay? So perfect square trinomials. Notice if you're catching that, that's a perfect square, that's a perfect square. It certainly saves you a lot of work. Okay, so that's number 50. Let's see, the next one we'll take a look at is number 51. And we're also going to hope this is a perfect square trinomial, because we're on a roll. Certainly no guarantees, though. Okay. Notice 25 is a perfect square, and in fact, that's a 1x squared. That's a perfect square. Okay. So the square root of 25y squared is 5y. The square root of x squared is x. If I multiply 5y times x, I get 5xy. I can rearrange the x and the y anytime I want. And if I add 5xy to itself, I get 10xy, and that's what I'm looking for. Sorry about it, I got a train going past here. So the factored form of this trinomial, it's getting a little crowded in here. Try to section that off some. Is 5y. Oh, notice this one's positive, so it was a sum of positive terms plus x, the quantity squared. Okay, so the factored form of that is 5y plus x, the quantity squared. If you're not picking up on perfect square trinomials, there's something in front of your first term, so you would multiply 25 times 1, you would get a 25, list all your factors, and you'd be using the box method. Okay, so you can still solve that using box. Alright, so that's 51. We're actually going to take a look at 52 and 53, because these are more complicated than I really like to have us work on. But notice number 1 on the list is GCF, and you can get an x squared out of there, and out of there. So that would actually be the first step. I don't always speak my way through my list of concerns here, but if you're having a tough time factoring, you want to refer to that list for every single problem. Okay, so there is a GCF of x squared. You factor that out of each term, and that leaves you with 49y squared. Okay, so here we've got 49y squared. Right here you'll have, I was seeing if anything else would factor out, but 7s, nope, that's all we're going to get. And then 84y, and finally a 36 plus 36. Okay, so we factored out our GCF, and these are awfully big numbers. If you multiply 49 times 36 and list all the factors of that big old number, you will be able to solve the problem, but it is rather daunting. So at this point you would be hoping to say, well, look, 49 is a perfect square, 36 is a perfect square, this is worth looking into. So the square root of 49 is, there let's move this a little bit. Square root of 49 is 7. Square root of 36 is 6. If you multiply 7 times 6, you get, I reverse these numbers. Darn it. Well, I'm going to reverse them right back because I wasn't supposed to do that. Alright, so notice that was an 84. This is supposed to be an 84. Sorry about that. Okay, so picking up where we left off. 84. Alright. So, if I multiply 7 times 6, I'll get 42. And if I add that to itself, I'll get, off my paper. Well, I'll zoom out a little bit. Okay, that would give me 84. And notice that's the middle term. Okay, so this is a perfect square trinomial. And that means the factored form would be 7 you're going to have to realize it's a y, 7y. I mean, really, when I took the square root of 49, I should have taken the square root of 49y squared. Sorry about that. So that would be a y, that would be a y, that would be a y. And then this 6, it's going to be plus getting rather distracted by the noises outside. Sorry about that. Hopefully it'll quiet down out there. Okay, so it'll be 7 plus 6, the quantity squared, and this x squared has to be in front. So the factored form of this trinomial is x squared times the quantity 7y plus 6 squared. Okay, that's 52, and we're also going to tackle 53. Another perfect square trinomial, I hope. Let's see. I'm going to try zooming in a little bit here. Maybe make it a little bit easier for you to see. Oh, let's go one more. Notice that, let's see, GCF, I can get an x out of each term. I can get a y out of each term. Alright, so number 1 on the list is GCF. And we've got to factor it out. So we can get x, y out of each term. And that's going to leave us with 49x squared plus 42, let's see if I can keep these numbers in the right order, plus 42xy, and then plus 9y squared. Okay, and we want you to notice that 49 is a perfect square, 9 is a perfect square. Alright, so the square root of 49x squared is, I'm going to leave myself some room to write the final answer, so I'm going to come down here. The square root of 49x squared is 7x. The square root of 9y squared is 3y. When I multiply 7 times 7x times 3y, I get 21xy. If I add that to itself, I get 42xy, and that's what I'm looking for right here, 42xy. Okay, so this confirms that this is a perfect square trinomial. So the factored form is 7x. Everything's positive, that's convenient, plus 3y. This quantity is squared, and that xy, you have to bring that down. Okay, so here's the factored form of our original polynomial. That's 53. I think we'll stop there.